Alrighty. So let's get this show on the road here. To get us started, we have some new notation and vocabulary. Now, if you are writing this on just a separate sheet of paper, which you should be if you don't have your printed notes, it's okay if you paraphrase a little bit. I will point out the really important stuff that you absolutely need to have written down. First and foremost is going to be this. Oh, I circled half of it. This is going to be really important to us, so make sure we have that down. But before we get there, I want to kind of reiterate what it is we're talking about, what I just circled. So an ordered pair normally has X and Y. Okay, that's what we're used to. That's what we've seen since like day one talking about coordinates. And in this situation, when we have X comma Y, X is the input value, and Y is the output value. Meaning that if I have a function, whatever is in X's place, that's what I'm putting into the function. After the function does its thing, I'm going to get my output value or the Y value. Now today, we're not going to use Y's. Instead, we are going to replace our Y's with this. Okay. The way we say this is f of X. So this is another thing that's going to be super important to you. I'm going to box it off so we know. The letter out in front, as I have already circled for you, the letter out in front is the name of the function. So just like you and I have names, our functions also have names. And it doesn't always need to be F. We don't all have the same name, so our functions won't. You can use really any variable. F of X is just the most common one that you will see. And then the variable in the parentheses, that tells you what letter you're going to see in the equation or what your input values are. So now, instead of X, Y in our ordered pair, we're going to have X, and we're replacing our Y's with F of X. This is also important. Right? Now, like I said, it doesn't always need to be F and X. It can really be any letter, just like we have different names, so will our functions. So you could have something like G of X. You could have H of T. It doesn't always need to be X. You could have, I don't know, Z of N. Doesn't really matter. We just need to know what each of those letters represents. The outside one is the name. The inside one is the variable that you'll see in the equation. Give everybody about 10 seconds to make sure they have the important stuff written down here, and then we will move on to the next slide here. All right, so this is what we call function notation. And that's what we're going to use today. So let's put this into practice. Our whole I Can today was about interpreting and comparing slopes. So there are 3 basic steps when you're going to compare slopes. In order to compare, we actually have to have some data. So the first thing that we're going to do is find the slope of both functions. Okay, if we want to compare, we got to know what we're comparing. Then after we find the slope of both functions, then we are going to go back and see, what is it actually asking me to determine? I'm going to ask you one of 2 things. I'm going to either ask you which one is increasing faster or which one is decreasing faster. Now think back to Monday's lesson. If I want to know which one is increasing faster, what type of slope am I looking for? Yeah, thank you, Evelyn. Positive slope. So if I ask which one is increasing faster, you're looking for the biggest positive number for a slope. Which means if I'm asking about decreasing, which one's decreasing faster? Yeah, thank you. I'm going to have I'm going to be looking for the biggest negative or the most negative number for my slope. Once we have both of our slopes and we look for the biggest either positive or negative number, then we're going to choose a winner and name that winner. Can you guys give me a thumbs up or a good when you're ready to go on to our first example? Give me a thumbs up or a good when you're ready to go on. Awesome, lots of goods. As a reminder, if you miss something or maybe you're just trying to frantically write stuff down, at the end of the day, if you miss something, come back and check out the Jamboard. It will be filled in so you can kind of look at anything you might have missed. So let's go to this first example. All right, I want to compare the slope of this graph and the slope of this table. So if we think back to our first step, I need to find the slope of both of these functions. Okay, now they're both functions. We can find the slope of both of them. We're just going to use different methods. For our graph, remember that we read it from left to right. So I'm going to start with my leftmost point, which would be up here. And then I need to figure out how to get to the right point. Now, remember, we got to count our rise over our run. So you're going to count how much you go up or down, and then how much you go left or right. So to go from that left point to the right point, am I going up or down? Ooh, we got some confusion. To go from the left to the right, we're starting with the one that I've circled. To get to this other one down here, we have to count down, okay? And what I like to do is draw those little hippity hoppities. So 4, 5, 6, 7. There we go. Sorry, my computer screen lags a little bit. But as you can see, I'm counting those spots all the way down to see how much I moved down. And if we count those, I've moved down 8. So that means my rise is going to be -8 since I moved down. And then my run, I'm moving to the right, and I'm going 1, 2, 3 spaces to the right. Since I moved to the right, that's going to be a +3. Can I simplify that? Yeah, Caitlin says, no, I cannot. 3 does not go into 8, nice and pretty, unfortunately. So instead, what we're going to do, we're just going to leave it as a fraction. I'm just going to leave it as -8/3. Okay. Now let's move on to the second one. I found one slope. I need to find the second. In our table, remember, we can pick any 2 points. I like to just pick the top 2. But you can pick other ones if you want. So I'm using -1, 3 as my first point, and 1, -4 as my second point. And then I'm going to use my slope formula, which I'll write up here for you because I'm going to have you guys find the slope. Okay. I want everybody to take a moment, and using our slope formula, I want you to find the slope between those 2 points. Okay, I am going to call on someone, so have your answer ready. You should be writing this on a separate sheet of paper so you are ready to go. You're finding the slope between -1, 3 and 1, -4. Remember, our 3 steps were label, plug in, and simplify. I'm going to call on someone, so make sure you're ready. Emery, what did you get as your slope here?
I'm sorry, what was the question?
You're finding the slope between these 2 points. What did you get as your slope?
You see, I've been working on it for like, I don't know, but I couldn't find it.
So we're gonna work through it together, Emery. First step is label. What comes first, X or Y, sir? Just keep your mic on. We're gonna work through it together because I'm sure you're not the only one that has questions. Emery?
I don't know what's up with my volume. It's kind of low. What'd you say?
No, I can hear you. You're fine. Just leave your mic on. We're gonna work through it together. What I'm plugging in I'm labeling first. What comes first in ordered pair, X or Y?
X.
Yep, so we're gonna label X, Y, and then I'm gonna make this my first and this my second. So according to my formula up here, what's my Y2 value then, sir?
-4.
Yep, so we're gonna do -4 minus my Y1 value, which is?
3.
Yep. And then for our X2 value, we do 1 minus our -1 value for X1. Now help me out, Emery. In the denominator, I now have 1 minus -1. How could I rewrite that?
1 plus +1.
Yes, good job. Oh, we're going to change that to a positive. Oh, eraser, come on. Cool. Thank you so much, sir. We worked through it together. So who has my final answer for slope then? For this one. Yes, good job. We get -7/2. Now, again, 2 does not go nice and pretty into 7, so we're just going to leave it as a fraction. Now, let's look back at what we have to do. So, we did step 1, which says find the slope of both functions. Step 2 says to determine what the question's asking. So, is it positive or negative? If I look back at my question here, it wants to know which one is decreasing at a faster rate. So I am looking for the biggest negative slope, okay? All right, so I have -8/3, -7/2. If fractions aren't our strong suit, now you can't give me a decimal answer, but you can use decimals to help you. If we look down here, I've given you a hint. If you're unsure, convert it to a decimal in your calculator. So if I don't know how to compare 8/3 and 7/2, if my brain is just not working that way today, what we can do is literally take out a calculator and type in 8 divided by 3. And literally take in a calculator and type in -7 divided by 2. Can one of you tell me what you get when you plug in -8 divided by 3? You all have that calculator extension, so. Or you can like use your phone if you need real quick. Yeah, it's I got a -2.6 and a -2.7 in the chat. It's -2.6 repeating, so yeah, somewhere between those. And -7/2 is -3.5. So if we're comparing those, and I want to know the biggest negative, which one is it going to be, Soraya? Which one of those slopes is the bigger negative number? We're comparing our two answers. Which one is the bigger negative number here? Okay, so the first one, negative 2.6, technically, if we were to negative 2.6 would be greater than negative 3.5, but we want the bigger or the most negative. I guess that's the better way to put it. So actually, in this case, negative 3.5 is going to be the most negative here. So this slope over here is going to be our winner. Now, when we name it, though, we're not going to call it the first one or the second one. We're not going to call it the table or the graph one. We said before, just like us and just like our basketball players, our functions have names. And these ones are named for us. They told us that the table one was named f of x. And the graph one was named h of t. So once we find our answer, you have to give me the name to earn credit. So our one that is decreasing at the fastest rate would be f of x. Unfortunately, even if you go through all this work, if you tell me the second one or the table, I can't give you credit. I need to know that you know how to use its name. Can I get a thumbs up, thumbs down on this first example? Tell me how you're feeling. All right. If you didn't fall in the good category, we're going to go through one more example here. Hopefully make sure at that point we feel good about it. All right. So here again, we have a graph and a table, and we want to compare these two, compare the slopes. For the graph, remember, on the last example, I gave you the points. This time you have to identify two obvious points for yourself. So you might pick different points than I do. Remember, the only thing we have to make sure that the point lies on like one of the crisscrosses of the coordinate plane of the grid lines. So I'm going to pick this spot and this spot. Okay. And then we're going to count our rise over our run. Does anybody have that slope ready to go with our graph? Count your rise, count your run. Somebody have my slope here. Yeah, thank you. You are killing it today, ma'am. It is 2/3. Let's talk about why. So remember, we start with our leftmost point, which means I'm going to start over here. And you have to kind of give me a roadmap to get to your second point. And we always start with how much we go up or down and then how much we go left and right. So here I move up. Ooh, I did not mean to erase that. Here I move up 2. That's where I got my rise of 2. And over 1, 2, 3. That's where we got our run of 3. Since we can't simplify it, we're just going to leave it. Bada bang, bada boom, 2/3. All right, so I have the slope of that first function. Now I want to find the slope of the second. So I'm going to pick 2 random points. Again, I just like to pick the top 2, but you can pick others. And I want everybody to take a moment. I'll even write your slope formula up here, even though you should have it written down somewhere for you. Ooh. I want everybody to take a moment and find the slope between these 2 points. I am going to call on people. Be ready. Give you about 30 more seconds before I'm calling on somebody. Make sure you're finding the slope between those 2 points. Finn, what do you think? What'd you get as your slope? What don't we know? Where did we get confused, Finn? Nobody asked questions at the start of class when I went over the slope formula. So where are we getting confused at? Yeah, thank you, Evelyn, for helping us out. It is 5 halves here. We did 9 minus 4 over -4 minus -6, which gives us -4 plus 6. So we end up with 5 halves. Now we need to compare these two. So between 2/3 and 5 halves, again, if you're not super great at comparing fractions, that's okay. Remember, we have a decimal trick. We can convert them to decimals. 2/3, if you type in 2 divided by 3 in your calculator, you're going to get 0.6 repeating. And if you type in 5 divided by 2 in your calculator, you're going to get 2.5. So my question is asking which one is increasing at a faster rate, meaning I want to know which one is the most positive. Who can figure out which one is our most positive? Yeah, we got a couple right answers, and thank you so much for using the function's name. D of x is the one that is increasing at a faster rate. And where did they get that name from? If we look, it's always going to be labeled for you. This one's labeled D of x, that's its name. And this one is labeled f of x, that's its name. All right. What questions do we have?